Hello Labmentix team. This week our project is about aerial object detection and classification. We use CNN and YOLO, which are deep learning models, to classify and detect whether the object is an bird or drone. So we have a project. So that project helps to detect whether the image consists bird or else drone. This is about our project. Before going into the project, why we need to solve this project? So the current mechanism of detecting object is crucial. In an image there would be many things like objects, blurry image, or else clear image, or else some disturbance. So these are all the factors which can affect to detect an accurate image. This helps to various departments, forest department with surveillance cameras, or else home camera purpose, CCTV purpose. These are all the real time implementation applications. So for this, detection of object is very much important, that can help to save time to any of the department. Now let us go back to the our project. So our project main aim is to detect with good accuracy. For that we use deep learning algorithms for this to implement. One is CNN, YOLO and TensorFlow. This helps our project to identify and give the accuracy metrics and classify objects, and using interface streamlit helps outcome to present beautifully in an interface. Now let us go in deeper and find insights from our project which has been deployed. 1 minute. Yes, now my screen is visible. So let us go into our project. First we will see what all we have in our project, like so before going into the outputs, let us see what we have. We have classification dataset, and one more, we have object detection dataset. So we have test, train and validate. These are the three principles we follow when we use an deep learning or machine learning algorithm. So we have birds dataset, drones dataset, which is going for test, and we have birds dataset, again drone dataset. For train purpose, for validate purpose are same. These are the three major factors where we need for training or testing or validation purpose. So this dataset is especially for classification. Now for object detection we use same, again test, train and validate. These also have same type of images and labels. Labels are something we need to assign for objects after detection. Now what else we have, like these are some sample results. So the sample results are nothing but like classification. This is final output what we will get. So as we can see a bird in our output, so it has predicted bird, that is important. So object, so this is second type of solution. So here we use YOLO mechanism, which is famous for using to detect and identify object, and it is showing as bird, you can see here. And what else we have, we have for path checking, we'll check whether the object is present at this area or not. If that is not there, else part will execute. This is configuration where everything is present. And data classification, we have train, test and this kind of things we are explaining to the TensorFlow here. And for evaluation, what purpose we are going to evaluate the data, here everything is given, where confusion matrix is there, and predicted value is there, true value is there, and classification report is there, everything is present. This is CNN model, convolutional neural networks, which helps to identify the classify the objects, like similar kind of objects are classified into various groups. So ReLU is the activation function, sigmoid is other activation function. Here we have, this is the input shape and size, and where training is here, we have taken TensorFlow, Matplotlib to plot the graphs, and we have taken configuration, we have taken classification of data, and we have taken the models to build, which is H5 and other PKL files. Once the epochs is trained, then it is stored into a path, and next we have value for every accuracy what we have predicted. So epochs is done here. For YOLO, we have training path here, where we will train for the object detection. This is second model. Again, this model is saved in a folder. So we have next app deployment. First app deployment, we will go for Streamlit interface. So this helps us to make beautify the output and attractive to the end users, where everything is developed and final state we will going to deploy in this. And this is an example. So already I have shown this one, object detection, and this is readme file. Requirements, we need these requirements: TensorFlow, NumPy, Pillow, Skitlearn, Matplotlib. These are all the minimum requirements to make sure that project is run uninterruptedly without any issue. These are the libraries that are mandatory to run this project. And this is YOLO output, and here we can see here we can see epochs is done for the 10 epochs. Each epoch has taken time approximately 81 seconds, 67 seconds, 56 seconds, 67 seconds, based on the accuracy. So each epoch helps to improve the accuracy. At the final epochs, 10th epochs, we have achieved 98.72%. And precision, recall, F1 support are the metrics for prediction. So 96% was the prediction for a bird, 98% recall, 97% F1 score, 121%, 121 is the support value, and similar to the drone. And accuracy, we have achieved 97%. And next we have again trained the epochs for YOLO model. This is first we have done for CNN to classify the objects. So again we have done to identify the objects, we have used YOLO. Again we have trained the epochs 15. So each epoch was trained about 20 minutes. 25 minutes was highest time, 20 minutes is the highest time. and final output we have achieved this one, as it shows the images we have 448, 663 instances, and their values. Here birds are 217 types of birds, 225 different types of drones are present, and next we have cross-checked whether everything is present in our YOLO interface or not. Everything is present, every image is we can see every image. So images are around for YOLO, so there was 224 images for object detection, and finally this is where we hosted our website using this URL, which has helped us to store the interface and models, and helps to identify and give the accurate scores in interface. Later, once after finishing it, we have made it to push into the repo, git repo, but we faced a lot of issues because our models are huge large models, where we need to damn sure we need to use LFS storage mechanism, and and finally we use a forced mechanism to store everything in our git repo. And here where we can see, and controls. So classification is, first we need to browse for the files. We can keep any file like that can have a bird or else drone, so it can easily able to identify. Using classification model, we can keep the decision threshold value. This means the accurate results you need. If you need 70% accurate result, you can check here. So where we can upload our file again. So this is file, and we can run the classification here, and finally here you can see this is a bird, and this confidence of our model's accuracy is 99.42%. It says it's a bird. And YOLO, this is an other model which can help our system to identify the object. So here I want to keep again 70% accurate result. So here it is saying that 84% it is a bird, which is a squared between near the bird. So at the last it says it's a bird, only birds detected in this frame. This is our final result, and this is about our project. I think I have explained everything, and clearly with brief report, and brief project repos, and brief introduction and everything. I think I have been satisfied doing this project. This project helped me to learn many things, to work on large files, to train large files, and make sure that it is hosted in our web page, everything. And in future we can do cloud deployment using AWS, Azure, GCP, or else we can use Docker, anything to the cloud integration mechanism. This helps our system can handle any type of object, or else any type of bird or drone. And cloud platform helps us to make give a better configuration than present we have. Thank you for giving this wonderful opportunity to tell about this project. This is a wonderful project that ever I done in my history.